Last assignment. Kinematics.
So that's assignment 10 or?
This is assignment number 10. It's a plate cam that if we had a little more time, we would do another 3D print of it, but there's too many people to do it all. All right, in chapter 22, section 22-2, plate cams. Read through that and get a little more information on it. And then on page 109 or 848, assignment for unit 22-2, plate cam assignment 2. Complete the assignment to design a plate cam based on the information given. Make a drawing of the profile of the plate cam in place of the chart on the drawing, and I'll get back to that in the textbook, showing the angular displacements every 18 degrees or 12 degrees. Dimension the drawing following the example shown on page 94, as well as page 95 in the textbook. The drawing will include the cam displacement diagram, as well as the cam profile and a side view. It would probably be best to use a C-size sheet for the drawing. Not probably, you should use a C-size drawing for that. All right, this is significant because this is important, the 18 degrees and the 12 degrees that we'll get to. All right, to speed the process up a little bit, you will not have to draw and figure out what the cam displacement diagram is. It's going to be furnished for you in D2L or on the M drive as a starting point. So starting point, and you can use the C-size title block without any scaling. There's going to be no scaling factor, it's just going to be a 1-to-1 ratio on that. You don't need to use the bill of material. There's not going to be any bill of material necessary on this drawing. So you're going to go in and look for, in the CAD folder on the M drive or in D2L, CAD 255 kinematic drafting folder, AutoCAD drawing folder, CAD 255 assignment 10 drawing as a starting point. Title is plate cam profile, drawing numbers KIN 255-10. Due at the end of class Wednesday, May the 31st, which is a week from today. And remember, there is no class, no school on Monday. It is Memorial Day, holiday. So you get a little extra time, and so will I, to grade papers. All right.
Mr. Chairman?
Yes.
On that, what you were discussing there, I'm looking at it on, it's the assignment 10 plate cam profile MM. You were talking about that dimension of 18 degrees.
Yes.
I don't see that in here.
Really? On the
So displacement every 180 degrees or 120.
oh, maybe it's 180 or 120. Okay, don't worry about that. It will be explained in just a moment.
Okay. It's a 0, not a degree mark on. Oh.
All right. Number 2, design a plate cam that will activate a 1/2-inch diameter roller follower as follows. It's going to rise 1.5 inches in 180 degrees with harmonic motion. It's going to dwell 30 degrees. It's going to drop 1.5 inches in 120 degrees with modified uniform motion. It's going to dwell for the remainder. There's something called a prime circle that has a diameter of 3 inches. The plate thickness of the cam is 1/2 inch. The shaft is a 1-inch diameter hole. The hub is a 1.75 or 1 3/4 inch by 1.5 inch long hub, and you will size the key seat to suit, although you'll probably see in the example drawing it's already been done, hint hint. So you can verify that. The textbook says add a chart to the drawing showing angular and radial displacement. That is not part of the assignment. So disregard that in the assignment, and the scale is 1-to-1. Here's what your drawing is going to end up looking like. So that ought to take care of the lecture. Any other questions?
So we just need.
Okay, I'm just kidding, all right?
We just need to draw that.
You are going to draw this. There is, in D2L, a PDF of the drawing. So if you go back to D2L, and go back to content, go back to content, go back to content, go back, go on. Of course, it's going to be slow today. All right. There is the AutoCAD start drawing available in D2L, and that is the CAM displacement diagram, and there is the PDF of what the drawing is going to look like. And once the lecture is done and I turn off the video camera, I will raise the screen and there'll be a sample drawing here on the board that I will leave that you can reference against. All right. When you insert the starting drawing, you'll get this basic diagram. So I'm going to go ahead and insert this into this drawing off to the side here. So you can access that off the M drive. CAD 255 assignment 10 is going to look like this. So it's going to have some funny line types and line weights and all that kind of stuff. It is a block at this point. You need to explode it in order for you to get rid of this verbiage right here. All this is just verifying that this is the drawing that you're going to start with. X enter is explode in AutoCAD. Once you explode it, it will go back to the layers and the line types that it was created as. The reason it came in with hidden center lines in it is because that's the layer that was current at the time that I brought it in. If layer 0 had been current, it would have looked more like this. Exploding it will allow you to get rid of this. Calvin.
Okay, you got one in the D2L, right?
Yes.
Okay, if you open up that, and I just clicked on it and deleted it, the words.
Yeah, okay. Yes, because you just opened it. I inserted this into the drawing as an insert command, which brings it in as a block. If you just open it up, that's fine. I mean, you can start there. That's the idea.
Put a title block
I'm incorporating this into another drawing.
Okay.
To let you know that you need to explode it. Then, as you're doing that, so all of the divisions and everything are all there ready for you. Modified uniform motion is a straight line with arcs at the end of it. This is a 1.5 inch rise and drop. The radius of this little arc at the end, up here at the end, is half of the rise and or drop. So that's 1.5 inches. The radius is 0.75. If you were going to draw this, to modify the start and the stop so it doesn't start abruptly and stop abruptly because it's just a straight line that has a hard stop and start to it. That's how that radius came to be. Just so that you realize that's what's going on. And then just like you did with the CAM displacement diagram project assignment number 9, you're going to add in a linear dimension and override the text in here to get rise 180 degrees % D for the degree symbol harmonic motion. Label 0 degrees, 180, 210, 330, and 360. All right. The drawing itself, example, is on page essentially what it would look like is something like this.
What page is that?
This is page 95. You would have what would amount to the front view, the circle that defines the hub, the circle that defines the shaft, and a keyway, and then a side view. This particular plate thickness is 3/8 of an inch. Ours is 1/2 inch. The hub diameter is 1 3/4 inches, and it's 1.5 inches long. If this is 1/2, it's going to protrude out from the back of the face of the cam by 1/2 inch, and it's going to protrude out at the front by 1/2 inch. 1/2 inch, 1/2 inch, 1/2 inch equals 1.5 inches. So it is centered off of the plate itself. Gordon?
So do not use those dimensions in the book.
Correct.
Use the dimensions off the chart.
Use the dimensions off of the example drawing and the information that is in the assignment itself. This is just an example of what a plate cam profile drawing would look like.
Yeah.
All right.
Got it?
Now, everybody ready? Okay. The harmonic motion scale that you've already used in assignment number 9 has, counting up from the base, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 increments, which also has to have 10 increments along this way. 10 up, 10 across. And then as you put a spline line in here, again, you hit the little intersection points. I took out these bottom ones to just kind of clean it up and make it look a little more easy to figure out. So again, you're just making the spline. This is a line element. This is going to be, you could draw a circle in here that has a radius of 0.75 and a circle down here, and then draw a line that's tangent to the edges of the circle and then trim the circle out. So you get that little curve, line, curve, and it's all tangent. This modified uniform motion has 1, 2, 3, 4, 5, 6 vertical increments in it, but I still need to have 10 increments in this direction for accuracy in trying to create the profile edge of the plate cam itself. If this is 180 degrees divided up into 10 equal increments, how many, 180 degrees divided by 10 makes 18-degree increments. That's what came out of the textbook. If I take 120 degrees and divide it by 10, I get 12-degree increments. Okay? This is still 12 inches long, and if you took the circumference, 360 divided by 12, or 12 divided by 360, you get 0.03333. If you needed to figure out how far it is from here to here, here to here, here to here, in your diagram. That's why you did assignment number 9, is to prep you for this. And now you don't have to draw this, it's already been given to you. Okay? You don't have to draw it. I'm just explaining how it came into being. Okay. Now, let's look at this point right here. Well, actually, let's look at the front view. So I'm going to draw 2 center lines, and then I'm going to have a circle that is going to define my shaft, which is 1 inch in diameter. I have a 1/8 by 1/4 keyway, 1/4 inch by 1/8 inch. I have this that defines the hub, which is 1.75, but drafting or dimensioning standards say that I should dimension the circle in the view that shows it as a cylinder more than as a hole. Holes I can dimension over here with a diameter dimension, but I should not dimension it here in this view. It should be over here in the profile view. So there's my 1 3/4. Here's my 1.5 inch total. So this is 1/2 inch. This is 1/2 inch. The plate thickness and the amount that the hub protrudes out, we do not put the third dimension in here. That's superfluous. So that's the dimensioning that's required. Don't forget hidden lines, don't forget center line in your side view. All right, the textbook talks about a 3-inch diameter prime circle. The prime circle is the theoretical starting point for the bottom of the 1/2-inch diameter roller. The diameter shown, or the roller diameter is shown on this drawing as magenta. That's where the roller would start. As I create the plate cam, so here's the center of my shaft, and I want the roller to be at rest in this vertical position here. The rotation generally goes clockwise, which means that then it's going to have to rise, excuse me, the rotation is going to go this direction. It's going to rise based on the shape of my profile, based on the information that I have up here in my cam displacement diagram. How do I get to create that? Because I've got to radiate out from that. All right, I've got a center line here. If you do an array, and array this 18 degrees between these objects, if the array pattern has 11 objects in it and it arrays 180 degrees, you'll get 18-degree increments as center lines that radiate out from the center of the shaft. Questions on that? Okay.
So you're saying 11, which will give us
10
10 spaces.
10 lines.
Okay,
Yeah. That's how it works.
Right.
Okay. The 18-degree increments mark where the center of each roller position is going to be. And it needs to increment out a certain amount from the starting point, which happens to be this 0 degree right here. And it's at rest, so it's right, it starts, the profile starts right on the edge, right at the bottom of the profile diagram. Okay, first increment over, 18 degrees over. Unfortunately, there's some construction work that you will have to do. That's just the nature of the game. All right, the first increment over. I need to know what put the cursor right where I didn't want to. I need to know what is this displacement measurement right here at the first vertical marking. All right, so if I draw a line in here, I could just measure, but I would need to know where that point was. I could extend this down here and measure from here to this intersection point. But because I took the lines out to try to make it a little clearer, there's this vertical distance right here. I need to know what it is. So I'm going to go over here, and I'm going to click on it with my quick properties on, and I'm going to find that it is 0.0381 in length. That means at the 18-degree increment, the cam follower has to move out from the prime circle 0.0381. So the bottom of the edge starts at 0, and then the bottom edge of that cam follower is going to go out beyond that by 0.0831. Okay, that makes kind of placing that cam follower diameter a little more difficult than if I use the center of the cam follower as a starting point. So if I go a 1/2 inch off of the prime circle, which denotes the bottom, I'm going to go half the diameter of the roller.
Right.
So the diameter of the roller is a 1/2 inch. If I go a 1/4 inch off the prime circle, that will establish where the center of all my cam followers should be as I rotate them around by 18 degrees.
So your first one is half,
Right.
and that's 0.
Hmm?
And then go from there.
Yeah.
Great.
All right. So let's remind ourselves it's 0.0381.
81.
All right, if I go down to my drawing, here is my cam follower in its at-rest position. If I locate the center of this, I'm going to put a line in here, and I'm going to put center. Okay, there is the center of the cam follower. Does everybody see that? I've got the little object snap on. Okay, if I drew a line from there, that would locate the center of the first position of the cam follower, which is resting on the edge of my prime circle. Is everybody seeing that? All right, if I drew a circle, created a circle, that the outer edge of the circle matched this, it is 1/4 of an inch offset from the prime circle. Is everybody following the thinking on that? All right, let's try this. Escape out of there. I just drew that line in there. If I do an offset of 0.25,
Which is the,
and I offset the prime circle, and I come out, that is where the center of the first cam follower roller needs to be. Now do you see that? Because it coincides with the one that I just drew in here. That's the first starting point. Then, at 18 degrees out here, that I've made my increments of 180 degrees, divided by 10 gives me 18 degrees per revolution here. I need the center of the second position of the cam follower to be 0.0381 offset from that. Okay? I'm not going to put that second circle in there. All right, let's change that color just for right now. What do we make it? Let's make it green. All right. So there's my 0.25 offset. If I offset this one out 0.0381, then I will be able to position that second cam follower. All right, so if I offset 0.0381 and I offset this one out to here, notice that it goes right over the top of the one that was drawn. That's my offset. Every vertical increment is my next offset from the prime circle, not from the one that I just offset, but from the prime circle as my 0 base point. And I just start incrementing out. Okay, once I have that circle in there, which I identified in this sample drawing as this line right here, I came back and that's the intersection of this 18-degree line that goes out here and the offset line of 0.0381. That locates that point right there. If I copy, use the copy command, copy this circle, use the center point as my base point, and offset it to this point right here, that gives me the position. As a review, we're going to do the next one, and probably the third one. Okay. Back up here, my second offset distance. So there's 0, there's the first one. The second one is going to be a vertical distance of 0.1462. And since I'm here, let's do the third one. The vertical distance from the base to the intersection is
3051.
3051. Okay, at the second increment, I'm going to offset from my my 0 point, which is my starting point. I think I said prime circle. I meant to say that it's, so this kind of becomes my 0 base point. So I offset out here. This distance from here to here needs to be my 0.1462. So if I offset 0.1462, enter, and I offset my green baseline out to here, notice that it goes right over the top of that next one. Or if I actually drew a line from here to here and measured it, 0.1462 are my offsets.
Boink, boink, boink.
I copy, well, I could copy this one using that center point to that center point. Next one out, if I measured from here to the intersection of the offset, if I offset it out, so I've offset this one, 1, 2, the third one out is 3.3051. Brent.
I'm a little confused on the spacing, how you're getting that.
It's 18 degrees,
But they don't look 18, each one doesn't look 18 degrees.
but they are. Trust me.
Each circle is 18 degrees or each line?
Each line, not the circle itself.
Really?
The circle is going out, so there's more space between the 18 degrees. As it radiates out, that's what gives this little spacing in here.
Yeah, there's
Don't
one
look at the
circle.
circles. Look at the degrees between the radiated center lines. Don't let that confuse you. Just follow the procedure.
Okay.
You'll get it. All right? So if I measured from here to here, that's going to be my 0.3051. I keep working my way around till I get down to my 180 degrees. And then this position stays the same through a 30-degree increment. And then each of these are 12 degrees as I go around to this point, and then it's another 30 degrees. Once I have, question? Okay. Once I have all of these circles established out here, then it's back to my spline type line. Did I make a spline out of that? Oop. Yep, it's a spline. I hold the mouse just right. So it's a spline using a tangent object snap. So if you're going to draw that, here's what I would suggest. Turn off all your object snaps except for the tangent. And it'll look kind of funny to start off with, but eventually it's going to come around. And a few of them will not, they'll overlap the circle just a little bit. But again, we're just kind of getting as close as we can with the tools that we have to work with, which is AutoCAD. Again, there's probably some better software program out there for doing a profile of a cam. I'm just betting, I don't know. So we're doing the best that we can. Gordon.
So, splitting the circle, 180, on the right-hand side, you have 18 degrees, boom, 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 boom.
Right.
Then you do a 30 degree.
Correct.
Then from that 30 degree line, you have 12 degree, boom, 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 to the next dwell line, and then that gap is whatever
30
it is.
degrees. Both
30
dwells
degrees.
are 30 degrees.
So, in other words, you have 18 on the right, and according to how
Yes.
we are looking at it now, 18 on the right, 12, and 2 30 gaps.
Correct.
I don't see the 12s though.
That's on the left side.
On the left side over here. Alright, if I did, let's change to my dimension layer. If I did dimension layers and I did an angular dimension between here and here, 18 degrees. If I did one between here and here, 18 degrees. Between here and here, 18 degrees. Between here and here, whoops, here and here,
12.
Oh, I see,
Whoops.
okay.
between here, here and here, 12.
But between that
Here
point
and here, 12.
and between the center
Here
line and the
And here,
out,
12.
it's 30.
This is 30. This is 30.
Does that help you?
That makes a little more sense now.
There you go.
The trick is dimensioning the 180 degrees. If you have a line, now it's best if this is not one single line. That's the first little hint. If it's two line segments from some distance out here to the center and from the center out here to some distance, it's still in line at 180 degrees. If you do an angular dimension command and click this line and this line, it won't do it. It'll come back and tell you that the lines are parallel. Here's the trick. Take this one and rotate it 0.25 degrees or something like that. Cock it over just a little bit. You put it in here, and if you have whole numbers in your dimensioning style, it will read that it's 180 degrees.
Okay.
And then you can modify the text. But then when you go over to here, it might show up that it's 31 degrees. So once you get this dimension on here, rotate this back however much you went over. If you went over a quarter of a degree, come back a quarter of a degree, it's now parallel, but you've got this dimension in here, and then this one will actually come out. It's not cheating, it's just, you know, taking my lemons and making some lemonade out of it.
It's just AutoCAD.
Right, so let me sort of illustrate that off to the side. Let's see, did I put one out here? Oh yeah, I did. Alright, so out here I have a line segment here and a line segment here. And let's just make this a little. Again, if I do an angular dimension from here to here, lines are parallel. It doesn't like that. Okay, well I can fool you, AutoCAD. I can do a rotate command, this one, and use the center point. Positive number, I'm just going to say 0.25. I'm going to put an angular dimension in here. It gives me 180 degrees. This one is supposed to be 30. Oh, okay.
Until you're ready.
Just about.
Okay.
Yeah.
Just go ahead and say that.
So I've got my 180 degrees in here that I can do my text override on. If I go back to my angular dimension and pick this line and this line, well, it was not enough that it threw it off into 31 degrees. So honestly, I could probably leave it that way. And I can line it up. If it gave me an incorrect number, if this ended up being 31, because I rotated it over a little too much, again, I would just rotate this back minus 0.25. It would be perfectly straight and everything, but you know what? This is just a diagram. I'm not actually making it from this drawing. Now, if I were making a solid model of it, that's another whole story. And that's how I get my dimensions in there. That's the trick. Once you know the trick, it becomes easy.
Okay.
So you're welcome. I just figured I'd help you out. The biggest thing is kind of creating those offsets. I mean, you just have to do it one by one by one. And then it's a little tricky to get the spline in there. And if you went back to the first drawing, you would see that occasionally it goes.
What are the yellow lines?
Those are
The yellow
offsets.
lines are my offsets of my centers,
Okay.
of my vertical distance. So you can see that this profile does not exactly hit the bottom of the cam, but you know what? That's a pretty insignificant amount in thousandths of an inch, and it's not that critical, because once I get that profile, again, it's the tool that I have to work with. It'll do as close as it can to tangency. Some of them are closer than others, and it's gonna be fine. It would do what I need to do. It would actually do the harmonic motion rise, the dwell, and the modified uniform motion drop, and it wouldn't be that significant to create the drawings.
Super.
Any other questions?
See you Wednesday.
Manuel?
What is the diameter of the prime circle?
The diameter of the prime circle is 3 inches.
3 inches.
Yeah. That's in the textbook.
Oh.
If you have any questions after I leave, you'll have to wait till probably later tonight when I get a chance to upload the video, because I'm going to be busy for the next 2 hours in a meeting or thereabouts. Any other questions? And we have our wonderful work study person here that's going to monitor the lab for us, so that I don't have to kick you out and 8 of you try to get 6 computers in the library. All right.